Normalization is a process of organizing data into tables so that the data duplicacy and the data redundancy can be reduced. There are three major normal forms: the first normal form, second normal form, and third normal form, and we are going to focus on these three normal forms in this video. So let's start with the first normal form. In the first normal form, we try to take care of the functional dependency. That is, if there are elements or the attributes that are functionally dependent, then we try to put them into a separate table. So this example over here is an orders table, which is a unnormalized table. That is, everything is into one table. That is the orders table. So if we take a look at this table, you have order date, order ID, date, customer first name, last name, city, clerk first name, last name, description, quantity, and other repeating information of the items. So what we do with the first normal form, or when we are trying to take an unnormalized form table to a first normal form, what we do is we first try to identify the repeating elements or the repeating attributes in the given table. So in this case over here, the repeating attributes is the item description, quantity, and unit price. And the same information or the same attribute is being repeated for item 2 and item 3. And in the first normal form, we take in these repeating elements and put them in a separate table. So the same example, take these repeating elements, put them in a separate table, and this is how it's going to look like. So now what we're going to do is we're going to take this table and create a separate table called the item, and that item table is only going to take in or store the information that is related to items. In this case, the attributes of interest is the item description, quantity, and unit price. So in the second table that we have created for the items, it's going to have the item ID, description, quantity, and the unit price. And because we would still like this item table to be related to the orders table, we are also going to have order ID as one of the primary keys. So the output of the first normal form is going to be a table with composite keys or two primary keys. So in this case over here, order ID and item ID, and this table, the objective of this table is to have a separate table that is only going to store the information that is related to items. And with this, our table is now in the first normal form, so we can now move to the second normal form. So for your table to be into second normal form, it has to be in the first normal form. So you cannot directly jump to the second normal form. You first have to have your table in the first normal form, and then you can move over to the second normal form. So in the second normal form, what we do is we take in this table, that is the item table, which has two primary keys or has composite keys, and remove the partial dependencies. So remember, we in our other video we said that partial dependency is a case where you have an attribute that is dependent on only one of the two primary keys. So if we take a look at this first normal form table, you have order ID, item ID, description, quantity, and unit price. So in this case over here, quantity is related to the order ID and item ID, and unit price is also related to item ID and the order ID. But if we take a look at this attribute over here, description, it is not necessarily dependent on the order ID. It is functionally dependent on the item ID. So now what we do is, for our second normal form, we split this table into another table, and we then call it item description, or any name that you want, and that ID is only going to have the information of the item ID and the description of that item. So so this is our table from the first normal form, which had description, quantity, and unit price. and now we have and from that table we have now created another table we call inventory items, and that is going to store the description of the item. So you have order ID, item ID, quantity, and unit price that is dependent on both of these primary keys or the composite keys. Quantity is also dependent on order ID and item ID. Unit price is also dependent on the order ID and the item ID. But this field over here, this attribute over here, description, is only dependent on the item ID. So that's why our first NF table, in our first normal form table, we still had this case of primary partial dependency. So in our second normal form, we tried to remove the partial dependency by creating another table called the inventory items, and that table is only going to store the information of the item and a description. So with that, let's move over to the third normal form. So for the third normal form, the first thing is that your table must be in the 2NF. You cannot directly jump into 3NF without having your table in the second normal form. So once the table is in the second normal form, you can now move to the third normal form. And in the third normal form, we try to take care of the transitive dependency. If you recall from my other video, transitive dependency is a case where you have a non-primary attribute that is dependent on another non-primary attribute instead of the primary case, and that's what we call the transitive dependency, and that is what we try to resolve in the third normal form. So for the third normal form, let's go back to our very first table over here. So if we take a look at this table has order ID, customer first name, last name, city, clerk first name, and clerk last name. But the primary ID of this table is still order ID, but it is storing the information of other entities like customer and the clerk. So instead of storing the customer first name and the clerk details in this table, so that we don't run into the anomalies that we have discussed, that is the update anomaly, insertion anomaly, and the deletion anomaly, it would make more sense to have a separate table for the customer first name and the clerk last name and the clerk information. So remember, we talked about the insertion anomaly, the deletion anomaly, and the update anomaly. Just in case if we are to insert any customer information, we do not really want to run into a case where we are not able to insert customer information just because that customer did not place any order. So regardless whether that person or the customer stores made an order or not, would still like to store that information. So for this table over here, we would now like to have a separate table for the customers and the clerk. So now what we do is from this table we would now split or create two additional tables, customer and the clerk, so that we can have a separate table to store the customer information and the clerk information. So this would resolve the anomalies that we have discussed earlier. So having a separate table for the customer and the clerk would also resolve the insertion anomalies, deletion anomalies, or update anomalies. Should there be situations where we'd like to store the customer information, but because the order ID also must be inserted, we don't really want to run into situations situation where we cannot store the customer information just because that customer has not made an order yet. Okay, so now what we do is we now create a separate table called customers and the clerks. This table is now going to have the primary ID as the customer ID, and clerk is now going to have the clerk ID. And in this, our original table, the orders table, it's only going to have the customer ID and the clerk ID as the foreign keys. So this way, what happens is that if we want to know who placed an order, or if you want to know the customer who placed an order, we could just take in the customer ID and then look into the customer's table to track down other information. And just in case if there is we'd like to store the information of the customers who initiate an order but did not complete an order, that information or those customers can also, we could still have the ability to store the information of those customers by, when we have a separate table. And likewise, with the clerks table, with the separate clerks table, we would still have the ability to store the information of the clerk who are still in the training phase, but but are yet to create an order. So yeah, so this would help, or this is how we would normalize the tables. And the major objective of why we normalize a table is so that we do not run into the issues of anomaly and the data duplicacy. So hopefully these examples were clear and it helped you understand the concepts of normalizations. Just in case if it did not, just feel free to reach me out.